And then you compile and run, and something comes out. So what I have here is I've got the code. The picture changes immediately. So the code and the picture are always in sync. There's no compile and run. I just change things in the code, and I see things change in the picture. And now that we have this control key, and I can dial it up and down. So I can see what it looks like for big branches or small branches, and I can kind of converge on what feels right to me artistically. And this works for any number of the code. I just point to it, dial it up and down. And some of these numbers here, I know what they do, but it's still kind of surprising to see them do it. And other ones are just completely surprising. So I want to fill a circle. So I start typing context fill circle, and as soon as I start typing, I get this autocomplete list of the different fill methods. So those are the different things I could type there: fill circle, fill rect, fill text. And as I move up and down this autocomplete list, I immediately see what each of them is doing. So I don't have to imagine what it would do from the method name. I don't have to look at the documentation. I just see it immediately. So I want the circle, and I'm going to adjust the x-coordinate and the y-coordinate, change the radius a bit. And that looks about right. Probably should be yellow. So I'm going to set the fill style, context fill style, same autocomplete as before. Choose fill style. Give me white by default. And I can change that color code the same way I change any number. Point to it, hit the control key, and I've got a color palette. So I can choose a nice yellow for my sun. My cursor changes to a magnifying glass, and now as I roll over each line of code, it's highlighting in the picture what's being drawn in that line. So if I want to know what's going on in this function, I just kind of roll down the function and see what highlights. Hold down the Option key, and now as I move over each pixel of the picture, you'll see on the right it's jumping to the line of code that drew that pixel. So that drew. Do that right now. Say on each tick, his x position plus equals his direction times the time interval, 1/60th of a second, times some speed, which, I don't know, could be fast, could be slow. If it's negative, he walks backwards. And these are all ideas I can use for other enemies, but I think turtles are supposed to be slow, so that's a good speed for a turtle. The problem is, I don't want the player to be able to get up here yet. I want the player to bounce off the turtle and go through this little passageway down here. I'm going to bounce off the turtle and pause the game. So I pause the game, and now there's this slider up here, which lets me rewind through time, which shows my guy's trail. So now I can see where he's been. And when I rewind, this trail in front of him is where he's going to be. This is his future. And when I change the code, I change his future. So I can find exactly the value I need so that when I hit play, he slips right in there. Order, and you have a key, which is the value that you're trying to locate within the array. And you keep track of two variables, which are the lower and upper bounds of where you think that value could possibly be. Right now, it could be anywhere. And you look right in the middle of that range. What you find is too small, then the key has to be after that. You look in the middle of the range. What you find is too big, the key has to be before that, and you kind of keep subdividing your range until you narrow in on the value you're looking for. And in code, binary search looks like this. And from my perspective, it takes a key and an array, and then over here on this side, it's saying, okay, it takes a key and an array, such as what? Give me an example. We need something to work with here. So, for instance, my array might be A, B, C, D, E, F, and let's say, for instance, we're looking for the D. So now let's start coding. The lower bound starts out at 0. Over here it says low equals 0, nothing amazing there. Upper bound starts out at the end of the array, so high equals array length minus 1. And over here it says high equals 5. So I have my abstract formula in the code. Over here it's giving me the concrete value corresponding to these example arguments. So I don't have to maintain this picture in my head. It's just showing it to me. So now I need the index in the middle of the array. So I'm going to take the average of those two. Mid equals low plus high over 2. And, well, that's obviously not right. 2.5 is not a valid array index. So I guess I need to round this off. So I'm going to add the floor function, and it rounded down to 2. And I caught that bug literally the second I typed it, instead of writing the entire function in 20 unit tests. So now I get the value out of the array. And then I need to subdivide my range, so there's an if statement, which I'll just paste in here. Of course, if the key was smaller, then it would take this branch of the if statement and adjust the upper bound. Or if the key was C, then we would have just happened to find it on the first shot, and we'd return the index. So this is the loop. While 1, do all this. And now what we have are 3 columns corresponding to different keys. So I can see how the algorithm behaves for these different input arguments. And by looking across this data, I can develop an intuition for how this algorithm works. So I'm trying different keys here. And say I try looking for a G. It has to be less than or equal to high. Okay, well, I'll just put that over as the condition of my while statement. Low, less than or equal to high. And then that would break out of the loop. And I would return some sentinel to say that could be found. So here we have. Let me finish up there. And 1.2. And so what I have here is a plot of the voltage on the. I can hit play and watch it simulate out in real time. So now you can see what the circuit's doing. What I'm going to spread these out a little bit. So same circuit, just spread out a little bit. And I'm going to add the voltage at every node. So now you can see every voltage throughout the circuit. And I can even hit play and watch it all kind of simulate out in real time. I want to change its value. I just click and drag it. And now I see the waveforms changing immediately. And you'll notice that I'll just spread these out a little bit more. And now I'm going to replace each of these components with a plot of the current going through it over time. Now you can see everything that's going on in the circuit. You can see how the current changes. You can see how the voltage and the current changes. There's nothing hidden. There's nothing to simulate in your head. So what we have here rethink these things. You have to think, how can this new medium allow us a more immediate connection to what we're making? How can this new medium allow us to work in such a way we can see what we're doing? And it's really the same Hanover, and the rabbit's going to do something. And 2 things. One, this is going to move pretty quickly. And second, I'm going to be using both hands at almost all times. So I've got these different layers, the background, the midground, the foreground. I'm choosing which layer to move using my left thumb. I'm going to move my leaf to its position, move my bunny off stage, and start time rolling. And now I'm going to perform the leaf drifting down from the tree. Run it back, check out how that looked. The motion looks pretty good, but the leaf kind of needs to rock back and forth. So I'm going to pull out a rotation controller, run it back, find where the leaf is about to break off, and record the rotation. And I added a little flip there just because it felt right in the moment. It wasn't even planned. Stop, because I want to pan over, so I want to drag a whole bunch of layers at once. I grab all the layers into a list. I turn down the sensitivity of the background layers so they'll move slower for a kind of parallax effect. I only want to move horizontally, so I pull out a horizontal dragger and check out how it looks. I don't quite like the parallax, so I adjust the sensitivity a little bit. Try it out again. I like that better. So I get ready to go. I run it back to the beginning so I can kind of get back into the rhythm of the piece. The leaf hits, I wait a beat, and I start panning. And I don't know how many frames I waited, I don't know how long it was, I went when it felt right. So I pan over to this winter scene and kind of slow down and stop. And then I run it back, because I want to do something for my bunny, throw away those tools because I'm done with them. And wait until I think my bunny should move. And he hops away. And then I've got a few different poses for my bunny, so I pull those out. And then I find the point where the bunny's about to take off the ground, which is right there. I switch his pose, and I kind of toggle between the poses as he hops away. And then I run it back because I want to check out how it looked, and I'm just going to bring that up full screen for you. This is the piece. So I made that in 2 minutes, performing with my hands like a musical instrument. Very immediate connection.